So this video is talking about the skill of completing the square. So completing a square. So if I have x squared plus 6x plus 9, this is called a perfect square trinomial. It's trinomial because it's got three parts. A perfect square trinomial is because when you factor this, what you get is this. You got two numbers that multiply together to be 9, add together to be 6. That is x plus 3 and x plus 3, which can be rewritten x plus 3 squared. This is a perfect square. This is a perfect square trinomial. Completing the square is an important skill at a few different places in math, but the one pertinent to us right now is circles. So there are two things that we need. When you look at the standard form of a circle, you have x minus h squared plus y minus k squared equals radius squared. We need this perfect square trinomial and we need this perfect square trinomial. Now, this is the standard form. This is the standard, let me get my pen working, standard form. But sometimes we have circles that are in general form, and this is the general form. So we need to use this completing the square skill to take this hot mess, which is a circle, but be able to put it into the standard form, which contains two perfect square trinomials. And so in doing this, we're going to reorganize. We're going to reorganize this in general form, and we're going to group our x's, we're going to group our y's. And so when I group my x's, I have x squared, so I've used that, minus 6x, and I've used that. Now, there is a plus 1 here, but we're not even going to mess with the constants. We're just going to leave a space for this number right here. And this number I call the perfect number. That's like this 9 over here, like this 9 right here. It's the perfect number that will allow this to be the perfect, to be a perfect square trinomial. So we're missing that number. And we're going to figure out what it is here in a minute. Now, we are then going to group our y's together. And so I have y squared minus 2y. And we need another perfect number. And that perfect number will allow us to, once again, factor my y's into a perfect square. And I still have this plus 1. And there are different ways to approach this. I like to just get that 1 out of the way. Just straight up, just move it to the other side. We'll deal with it in a minute. And so if I move that over, let me rewrite this a little bit neater. X squared minus 6x plus the perfect number, plus y squared minus 2y plus the perfect number equals negative 1. Now what you'll notice is the number that we need that will allow us to factor this into x plus or minus times x plus or minus whatever it is. There's a very specific relationship, and the relationship where we find that number is that if you look at the middle term, the b, if you recall, this is ax squared plus bx plus c. That's the standard form of a quadratic. If you look at the b term and these little guys down here is that it's always going to be half the b term. It's going to be half the b term to get to this right here. Half the b term. Half of 6 is 3, and 3 times 3 is 9. So to get this perfect number, I need half of this multiplied by itself, because we have the 3 times 3 right there. Let me change colors. We have the 3 times 3. So half of the 6 is 3, and 3 times 3 is 9. So to get that perfect number, I need to take half of the b term and multiply it by itself, or square it. Half of the b term, square it, and that will give us the perfect number. So half of negative 6, so that's our formula. Half of negative 6 is negative 3, and negative 3 squared is positive 9. Make sure you pay attention to those signs. But I got to add 9. But the catch here is if I add 9 on one side, I for darn certain have to add 9 on the other side. So I made sure to add 9 on both sides of this equation. We do the same thing right here for the negative 2. So half of the b term squared. So half of negative 2 is negative 1, and negative 1 squared is 1. So I'm going to put a 1 right there. Just let me be consistent with my colors. I'm going to add a positive 1 there, but if I add a positive 1 there, I have to add a positive 1 there. But what that allows me to do is allows me to factor these two. These are now perfect square trinomials. This is a perfect square trinomial, and this is a perfect square trinomial. And when I factor those, when I factor x minus 6x plus 9, I get x minus 3 times x minus 3, which is x minus 3 squared. Let me erase this, get this out of the way. And over here, I have y squared minus 2y plus 1. That is y minus 1 times y minus 1, which is y minus 1 squared. And what you'll notice is that this equals, what does it equal? It equals this. Well, negative 1 and positive 1 is 0, so that equals just 9. I took this original equation, this one right here, and I changed the form. I used the completing the form square, and it is mathematically equivalent to this right here. And this is the circle that is located at the center, 3, 1. That's my h and k, and has a radius of 3. Just remember, this is r squared, so it's 3. That is completing the square in the context of circles. Don't be afraid to look for other videos outside of the ones I provide.